Hi friends, good afternoon. Welcome to my channel, Belagali's class. Belagali's class. Yes, my friends, I have done some multiple choice questions for 10th standard, you mean SSLC students, and as today itself, the exam they are going to finish it. Next is PUC second year CET exam. Main exam already yesterday got the results, and everyone is passed. You know your scores. 600 out of 600 in terms of thousands. The students are there, my friends. Miracle, wonderful results, my friends. Enjoy it. Like this. I hope you must enjoy with your CET also. CET, that is Karnataka CET, going to be held on August 28th and 29th, my friends. 28th and 29th. Still nearly 1 month time is there. As far as possible by me, I do some of the topics. I can't cover all the topics, my friends. All the topics. So, possible, I will do what? The chapters, my friends. And as you know, the method of teaching for the main exam is different, and the method of teaching for CET is different. Why? For the main exam, my friends, you have 3 hours 15 minutes. For a paper of 100 marks, you have 3 hours 15 minutes. Sufficient time. Whereas for CET, 1 hour. 1 hour means what, my friends? 60 minutes. How many questions? 60 questions. Then, on average, you have 1 example per minute. If you look at it, you will be losing some seconds, my friends. So, while answering for CET, even the seconds will count, my friends. So much sharp, so much bright, so much quick. As far as possible, you must introduce yourself, the time saving methods, my friends. Here, the examples, you must do the correct answer within no time. The time allotted is what? 1 minute, my friends. So, you must be very, very smart in answering CET questions, my friends. Options will be there down. Instead of calculating each example and marking, you will never mark, you will never attempt what? More examples, my friends. You can attempt more examples only when you have shortcut, or instead of shortcuts, the better word is time saving methods. You must use the methods where you can save the time, my friends. If you save the time 2 to 3 seconds per example, what I mean 2 to 3 seconds. If you save 3 seconds per example, 3 into 60 examples, nearly 180 seconds. 180 seconds means it is what, my friends? Nearly 3 minutes. 3 minutes means you can attempt what? 3 more examples. Saving of 3 seconds will cost you. You can attempt, you can do 3 more questions. 3 more questions you can attempt, my friends. Here, each fraction of a minute is very important. Ranking is there. That rank depends upon your score. Therefore, my friends, up to this time, what they used to do, 50% of your board exam they used to count. 50% they used to take for what? CET. 50% for the board exam, that is main exam. 50% for what? CET. They used to add them and they used to take the average of that. Now, this main exam, what you have already yesterday, the result, it is only for what? Just you have to enjoy your score. 600 out of 600, just you have to enjoy. That doesn't count for what? Your ranking in the exam. Your selection for engineering, nothing. It doesn't count there, my friends. Therefore, counting is your CET. Your efforts, whatever you wanted to show, your talent, you have to show where? In CET, my friends. CET performance. Purely your selection during examination means engineering selection based on your CET performance, my friends. Then I told CET performance means what? 60 examples, 60 minutes, 1 minute, 1 example. To attempt more questions, my friends, you must apply time-saving results, my friends. While doing the examples, I will introduce some time-saving results. How to save the time about this example. First, in the beginning, I will show the lengthy methods, the time taken by that method. The same example, then I do it by what? Time-saving result. You know the difference between the usual method and the time-saving method. For few examples, my friends, I will explain what? The usual method as well as what? The time-saving methods, my friends. Yes. Yes. To begin with, your mainly calculus depends upon what, my friends? Trigonometry. That trigonometry is done in PUC first year, but for the PUC second year, I will be starting with what? Inverse trigonometric functions. Inverse trigonometric functions. Yes, my friends, see. PUC second year, or it is 12th standard maths class, Belagali class. CET examples 2020, 2021, because you are going to appear when? August 28, 29 of what? 2021. Yes, my friends. First, I will start with inverse trigonometric functions. In brief, it is what? ITF, inverse, IT, trigonometry, F, functions, ITF. In this, my friends, you have minimum 2 to 3 examples. 2 you have, but the third example, it depends upon the examiners, my friends. Even you may have what? 3 examples on this ITF. Yes, my friends. In ITF, this half of the class will explain the basics, my friends. The main is domain and range. In 2017, the question on domain range of what? Sec inverse is appeared. The principal value branch of sec inverse x equal to dash dash dash. 4 options are given in the down. Therefore, my friends, even this domain and range of this ITF played a very important role, especially this. And for the main exam, normally 90% they used to ask what? Examples on what? Domain and range of these inverse trigonometric functions. Even for CET also, especially in 2017, one example is appeared, that is the principal value range of sec inverse, my friends. Yes, my friend, see, inverse trigonometric functions, 2 or 3 examples. First, domain and range. This range is also called as, I have written in brief, my friend. PR means principal, P means value, BR means branch, principal value branch. And this is I write here, my friend. Principal value branch. Now the same thing I have written in brief as well. Principal value branch is BR. That's what I have written in brief. Principal value branch of ITF, inverse trigonometric functions. This column is for the functions. Second column is for the domain. Third column is for the range or principal value branch. First, friend, either y equal to sin inverse x or theta equal to sin inverse x. You can think anything. This is angle y equal to sin inverse x or theta equal to sin inverse x. Anything. What is the domain? Closed interval minus 1 to plus 1. The same thing you can write in the inequalities form. Minus 1 lesser equal to x lesser equal to plus 1. Either this way or this way. First, only for the first I have written down. Next. Range. It is minus pi by 2 to plus pi by 2. Closed interval. Or minus pi by 2 lesser equal to theta. This, if it is theta, theta, if it is y, y. Or even sin inverse x. This is for x, this is for sin inverse x. Minus pi by 2 lesser equal to sin inverse x lesser equal to plus pi by 2. Instead of theta, you may write here It is sine inverse x. Sine inverse x. Second, cos inverse x. What is the domain? Closed interval minus 1 to plus 1. This is for the principal value branch. Closed interval 0 to pi, or you can write in this way. Tan inverse x. R. What is that R? Set of real numbers. This entire real numbers, my friends. Entire set. This is plus R. This side is minus R. Or you can write this is what? Minus infinity to plus infinity. Minus infinity to plus infinity. This is minus infinity to plus infinity. And this is what? Range. Minus pi by 2 to plus pi by 2. It is an open interval. Open interval. Remember. Cot inverse x. Set of real numbers. Otherwise, the interval minus infinity to plus infinity. Now, what is the range? 0 to pi. Open interval. Cosec inverse x. Domain is R minus this open interval. This is minus pi by 2 to plus pi by 2 closed interval minus singleton 0. Pi. Cosec 0 is undefined. Cosec 0 is undefined. Pi. Cosec 0 equal to 1 upon sine 0. What is sine 0? 0. 1 by 0 means what, my friend? Yeah? Which is undefined. Therefore, accept this value. For sec inverse x, sec R minus, open interval minus 1 to plus 1. And for the range, it is a closed interval 0 to pi minus this value, pi by 2, because sec 90, what is sec 90? 1 upon cos 90, what is cos 90? 0, 1 by 0 means what? Undefined. Therefore, it is the entire values between 0 to pi except at pi by 2. Yes, my friend. These are functions, all the 6 inverse trigonometric functions. This is the domain, and this is the range, or another name is principal value branch. Principal value branch. All 6 trigonometric functions are there. This is about domain and range. Domain and range of what? ITF, inverse trigonometric functions. Actually, this sec inverse, I think range is, this is appeared CET 2017, my friends. The range of sec inverse x is dash dash. Below, they have given 4 options. 4 options. This is appeared in CET, my friends. 2017. Remember. Next, I will mention the properties of inverse trigonometric functions we use while doing the examples. I will write first all, then you must remember. This is the first property. Sine inverse 1 by x equal to cosec inverse x for all x greater or equal to 1 and x is less or equal to minus 1 in between this. Cos inverse x is, cos inverse 1 by x is sec inverse x. The same. X greater means this is the interval, my friends. Here, see. This is minus R minus this. R minus means what? My friends, this is your entire interval. This side is minus R or minus infinity. This side is plus infinity. In this you have, this is 0, my friend. This is minus 1, this is plus 1. Except this value. X is greater or equal to 1 and x is less or equal to minus 1. Except this entire R, this is plus infinity. Entire R minus this interval, minus this interval. Remember, my friends, remember. This is for the cos inverse 1 by x is sec inverse for these values. Third, tan inverse 1 by x equal to cot inverse x. For all x positive, only positive values, my friends, remember. Second property, sine of sine inverse x equal to x. For all x between, but it is same. This domain of what? Their respective ITF. So this is for the sine of sine inverse x equal to x, then x takes the values between minus 1 to plus 1, domain of sine inverse. Second, same, cos of cos inverse x is x, same, tan of tan inverse x equal to x. X belongs to R here. R, my friend, x belongs to R. cot inverse of cot x equal to x for this. Cosec inverse of cosec x is x for all x belongs to this. Same. Sec of sec inverse x is x for all x belongs to R minus this is this is remember this second property. This is third property. Sine inverse of sine theta, otherwise instead of theta if you take y, that y is angle. Always the angle in trigonometry would denote by what? Theta. Therefore, my friends, I have taken theta here. Sine inverse of sine theta equal to theta for all theta belongs to where? Close interval minus pi by 2 to plus pi by 2. What is that minus pi by 2 to plus pi by 2? Which is the range of sine inverse x. Which is the range of sine inverse x. Then you can make use. Here your x belongs to domain. Then for that property, third property, your theta belongs to the range. Alright. Cos inverse of cos theta equal to theta. Theta belongs to 0 to pi, close interval. Tan inverse of tan theta equal to theta, open interval in this case for the tan, my friends, open interval. Open interval. Cot inverse of cot, theta belongs to what? Open interval 0 to pi. Sec inverse of sec theta equal to theta, or theta belongs to what? Sec here. It is close interval 0 to pi minus pi by 2. This is for the cosec inverse. This is for the cosec inverse. My friends, this is third property. One is the domain. Domain is always for the x, and range is always for the angle. Sine inverse of minus x is minus sine inverse x. Same domain. Tan inverse of minus x is minus tan inverse x. Domain of tan. Cosec inverse of minus x is minus cosec inverse x. For all x greater or equal to 1. Means only this side. Greater or equal to 1. That belongs to what? Closed interval 1 to open interval infinite. 1 to infinite. Only in this it is true. Then cos inverse of minus x is pi minus cos inverse x. For all x belongs to this. Cot inverse of minus x is pi minus cot inverse x. Sec inverse of minus x is pi minus sec inverse x. For all x belongs to this one. These are four properties of inverse trigonometric functions, ITF. These are four. I will mention another one or two, my friends. Another one or two. Yes. The next one, the fifth property. Fifth property. My friends, next property, which is the fifth one. Fifth one. Sin inverse x plus cos inverse x equal to pi by 2. This is true for all x belongs to minus 1 to plus 1. Only for this interval, my friends. Minus 1 to plus 1. This is R, this is 0. What is this, my friend? This is plus 1. This is minus 1. It is true only in this closed interval. Closed interval means what it is? It is closed interval. Closed interval. Means ends are included. Ends are included. Next. Tan inverse x plus cot inverse x equal to pi by 2 for all x means the entire number 1. Sec inverse x plus cosec inverse x is equal to pi by 2 for all x where x is greater or equal to 1. Means it is from infinity, closed interval 1 to infinite. This side is plus infinite. This side is plus infinite, this side is minus infinite. It is closed interval 1 to infinite. This is third property. Next, the sixth one. Tan inverse x plus tan inverse y equal to tan inverse x plus y upon 1 minus x1. Where x and y are positive and xy, this xy is less than 1, strictly less than 1. 5. If xy is equal, denominator becomes 0. In that case, this RHS becomes what? Undefined. To avoid it, this xy is less than 1. Less than 1. Next, tan inverse x minus tan inverse y equal to tan inverse of x minus y upon 1 plus xy. These are very, very useful properties, my friends. In doing one-type examples, we use them. What is it? Tan inverse x plus tan inverse y equal to tan inverse plus maintains in the numerator. Sign change. What is this? Sum. What is this? Product of these two numbers. Here x plus y, here it is x1. If the LHS is plus, numerator plus, denominator minus. If the LHS is minus, numerator minus, denominator plus. Remember, my friends. This is a seventh one. Seventh one under very, very useful formula. You have some examples based on what this property. What is it? 2 tan inverse x equal to tan inverse 2x upon 1 minus x square. Sin inverse 2x upon 1 plus x square. Cos inverse 1 minus x square upon 1 plus x square. Making use of the property, tan inverse can be written as what? Cot inverse reciprocal 1 minus x square upon 2x. Cosec inverse reciprocal 1 plus x square upon 1 minus x square. And what is this, my friend? You take the reciprocal. It is sec inverse 1 plus x square upon 1 minus x square. 1 plus x square upon 1 minus. You have to take the reciprocal of this. Sec inverse, my friend. Sec inverse. This is one very, very useful properties. All these are properties we use while doing the examples. Next, this plays a very important role, my friends, especially in doing first type of examples. It is a bridge, my friend. This Pythagoras theorem is a bridge. Therefore, what is Pythagoras theorem? ABC is a right-angled triangle in which angle B is 90 degrees. Then it becomes what? Hypotenuse. AC is hypotenuse. Then square of the hypotenuse equal to sum of squares of remaining two sides. So AC square equal to AB square plus BC square. Pythagorean numbers means they satisfy 3 square 9, 4 square 16, 9 plus 16 25. It is what? 5 squaring 25. This is 5. You can say whether it is 3 or 4, it is 4 or 3. 9 plus 16 is what? 25. The numbers which satisfy the Pythagoras theorem, such numbers are called as what? Pythagorean numbers or Pythagorean triplets. Pythagorean triplets. 3, 4, 5 popular. 5, 12, 13 popular. 6, 8, 10 usual. 7, 24, 25 popular. 8, 17, 8, 15, 17. Normally these 5 pairs, my friends, they are usually popular. And you must remember these two also. 13, 84, 85. This is 7, 24, 25. 8, 15, 17. 13, 84, 85. 20, 21, 29. Otherwise, my friends, if they give what? These two numbers. What about these two numbers? One is 8, another is 15. If you won't remember these Pythagorean numbers, my friends, you know, what is this? AC equal to, this is square root of 64 plus 225, which is 289, which is 17, my friends. Here itself you will be losing what? Time. So to save the time, you must know these Pythagorean numbers. Especially, my friends, these things comes. If it is 85, one number. Another number is, my friend, 84. Here it comes. Very difficult. Square minus square. Take the square root. In such cases, if you remember this, you can do the examples. Otherwise, you have to drop that example. Therefore, my friends, in such cases, these Pythagorean numbers play very, very important role. This Pythagoras theorem, yes. If you know two sides, if you know these two sides, you will be able to get it. If you know these two sides, then what is BC square? AC square minus AB square. What is AB square? AC square minus BC square. Like that, if you know the two sides, you can be able to find the remaining third side. So, my friends, this Pythagoras theorem along with Pythagorean triplet or Pythagoras triplets These sets are given here. 7 sets, my friends. Read these 7 sets repeatedly. Read them repeatedly. Read repeatedly, or read, remember. Read, remember, or read repeatedly and remember. Triple R, otherwise double R. If it is double R, what is it? Read and remember. Read, remember. This, read repeatedly and remember. Therefore, triplets, triple R. Yes, my friends. This is again what? The Pythagoras Theorem. Pythagoras Theorem with Pythagorean numbers. Next, my friends, by taking 2 minutes, I will explain what trigonometric ratios, my friend. What? Inverse trigonometric functions. Once again, what? These are sine inverse, cos inverse, tan inverse, cot inverse, cosec inverse, sec inverse. These are, what is this? It is the inverse of sine x. That inverse of sine x is denoted by what? Sine inverse x. Then, my friend, your sine x comes. Your cos x comes, your tan x comes. Yes, just by taking 2 minutes, my friends, I will just look at what? The definitions of sin x, cos x, tan x of what? Acute angle. This is acute angle. This is acute angle. When it is 90, you can denote either this or this. Acute angle. Everything you have done now for 10th standard, my friends, SSLC, not PUC first year. All these definitions you have done for where? SSLC, 10th standard, my friends. 10th standard. Yes, my friends. Just we will see what we mean by, yes, trigonometric ratios. Trigonometric ratios. Yes, my friends. Yes, friends. Just I gave what? Pythagoras Theorem, the statement. After that, Pythagorean triplets. 3, 4, 5, everything, that nearly 6 to 7 sets of triplets are given, my friends. Then again I want to explain from your 10th standard SSLC. Trigonometric ratios of acute angle. See, ABC is a right angled triangle, right angled at B, and angle C is theta, your friend. Angle C is theta. Then sin theta. What is sin theta? Opposite side upon hypotenuse. Opposite side upon hypotenuse. These are the definitions, my friends. Just I am reminding. Opposite I denote it as O, and hypotenuse I denote it as what? H. Instead of opposite upon hypotenuse, see, my friends, CET, even in writing also you must be very, very what? Brief. O upon H. Cos theta, adjacent upon hypotenuse, which is A upon H. Tan theta, opposite upon adjacent, O by A. Cot theta, adjacent upon opposite, A by O. Now this you can write it in brief, my friend. This is a sine. This is a sine. What is it? O by H. O by H. This is a cos. A by H. This is tan. What is it? This is O by A. You know what is cot, my friend? What is cot? Reciprocal of this. A by O. If you come like this, it is tan. If you go from down to up, it is cot. What is this? Sec. Sec is what? Down. Hypotenuse upon adjacent side. What is cosec? Cosec is hypotenuse upon opposite side. Sin, cos, tan, O upon H, A upon H, A, O upon A. If you go down, cosec, reciprocal, sec, reciprocal, cot, reciprocal. The same you can write, my friends. This lengthy one. This lengthy one. You can write it in brief, my friends. You can write it in brief. Yes, my friends. See the note. Right angled triangle. How many sides? 3 sides. Among the 3 sides, every trigonometric ratio has 2 sides. These are the 2 sides given, my friend. 2 sides given. In a right angled triangle, when the 2 sides are given, making use of your popular theorem, Pythagoras theorem, we can find the third side. Here for the sine, opposite and hypotenuse are given. We can able to find what? Adjacent side. What is it? Square of hypotenuse minus square of numerator, that is opposite side. If you remember the Pythagorean numbers, my friends, here, if it is 3 by 5, then what is another number? Remaining number is 4, Pythagorean numbers. If these are 12 and 13, what is the remaining number? 5. If these are 8 and 15, what is the remaining number? 17. If it is 7 and 25, what is the remaining number? 24. That's why, my friends, always you must remember these Pythagorean numbers. If you remember them, you can save time. They are the same time, time saving results or time saving bridge, my friends. Yes. Therefore, remember, sine theta is given O by H. We can go for what? Cos theta. What is cos theta? If you know these two sides, means what? Among the two sides, in writing the cos theta, one is used. This is given, my friend. And what about this? This you have to make use Pythagoras theorem. This you have to make use Pythagoras theorem. If you remember Pythagorean numbers, you can write immediately. These are the two given numbers here. These are the two given numbers. Sine inverse 3 by 5. I want to write from sine inverse to tan inverse. Among the two, one is useful. See here. Sine theta is O by H. In writing cos theta, which is using H is given, write it. Then you have to find this remaining by making use of Pythagoras theorem. If you remember Pythagorean numbers, directly you can write this number. I have written some result here. See. Sine inverse 3 by 5. I wanted to write from sine inverse to tan inverse, which is useful. What is tan inverse? Opposite. See here, tan is there. Opposite upon adjacent side. What is sine? This is opposite upon hypotenuse. This is opposite upon hypotenuse. Then opposite is used, tan. Then you wanted what? Adjacent side. What is adjacent side? Pythagoras theorem. Pythagorean triplet. 3, 5 is there, means directly you can write this number as what? 4. Therefore, this is your shortcut, time saving. Here, we are not doing what? 25 minus 9, 16, square root of 16 is 4. We are not writing. And even we are not drawing this right angle. No. Directly we are writing. Directly from sine inverse to tan inverse, sine inverse to sec inverse to cot inverse. The way of direct writing is one of the most popular what? Time saving result. It is bridge. You must pass that. Like this here, my friend. Sine theta O by H. What is cos theta? A by H. This A you must find by making use of Pythagoras theorem. Tan theta. Tan theta is what? O. You wanted what? This hypotenuse here. Again Pythagorean numbers like this, my friends. So, see here. Sine theta is O by H. What is theta? Sine inverse O by H. Sine opposite upon hypotenuse. Even for the sine inverse, what is this side? Same, opposite upon hypotenuse. Therefore, the sine or sine inverse, this ratio of the sides is same. Ratio of the sides is same, my friends. Here also it is opposite upon hypotenuse. Here also it is opposite upon hypotenuse. Therefore, from here to here, tan inverse, one is useful. What is tan inverse? Numerator is opposite side. Denominator is adjacent side. One is useful. O is given. Then you must find this A. You must find this A by making use of Pythagoras theorem or directly Pythagorean numbers. Here, my friends, we want to write sec inverse. Same. Hypotenuse H. You must by making use of what? Sec inverse, my friend. Hypotenuse upon. This is hypotenuse upon what? Adjacent side, which is A. This A either Pythagorean number, remember, otherwise you must calculate it. That is why making use of all this idea, my friends, right from trigonometric ratios of an acute angle, giving the definition of what? These 6 trigonometric ratios, I told what? Sin theta is O by H. What is theta? Sin inverse O by H. In sin theta also same ratio, opposite upon hypotenuse. Even in sin inverse, if you look at this ratio, it is nothing but what? This is opposite side, this is hypotenuse. If it is tan inverse, what is this? Opposite side upon adjacent. If it is sec inverse, hypotenuse upon adjacent. Remember, my friends, sin to sin inverse. The sides, ratio of the sides are same as in case of trigonometric ratios, same as in case of inverse trigonometric ratios. These pair of sides are same here and here. So I told here, this is sin inverse 3 by 5. I want to write from sin inverse to tan inverse. 3 by 5, what is it? Opposite upon hypotenuse, tan inverse, what is the side? Opposite is here, 3. What about the other side? You have to calculate by making Pythagoras Theorem. This you have to calculate by using Pythagorean numbers or Pythagoras Theorem. When 3, 5 are there, what is the remaining side? Is 4, it is the remaining side. See here, cos inverse told by 13 to tan inverse. Cos inverse told by 13 to tan inverse. What is cos inverse? Adjacent side upon hypotenuse. What is tan inverse? Opposite upon hypotenuse. Among the two, one is useful. Which is useful? Adjacent side, right. How to find it? Again, Pythagorean numbers. What is this? By Pythagorean numbers 5, 12, 13. Therefore, cos inverse to tan inverse. If you know this method of conversion quickly, without writing anything, you can very well save the time. See here. Tan inverse 8 by 15 to sec inverse. What is this, my friend? Opposite upon adjacent. If you can write opposite upon adjacent. What is sec inverse? Adjacent. What is adjacent side? 15. What is it? Hypotenuse. If you remember Pythagorean numbers, 8, 15, 17. You can save the time. Otherwise, again, square. Sin inverse to tan inverse. What is this, my friend? This is O, this is H. What is tan inverse? O. O means what? 7. This is the adjacent side. Once again, 7 and 25 are known. Pythagorean numbers. What is this, my friend? 24. This you have to write. Otherwise, it was very difficult. See, 625 minus 49. Then one number comes, square root of that number. You can spend what? Even more than 1 minute in getting what is 24. Then what about the question? That question will be another 1 minute. Then if you remember Pythagorean numbers, fraction of a minute you can do the example. If you do not know the Pythagorean numbers, that will take time, my friends. And this is how you must use this time-saving results. TSR. I'm not saying them as what? Shortcut method. No, this is time-saving results. Yes, my friend. Here one more is there. See. Sec inverse to tan inverse. What is sec? My friend, this is H upon A. What is tan inverse? This is O upon A. A is known too. Then how to find it? Hypotenuse is this, square. 5 minus the square, 4. 5 minus 4 is 1. Square root of 1 is 1 itself. This is how you can find from sec inverse to tan inverse. How? Hypotenuse upon adjacent. What is tan inverse? This is opposite upon adjacent. Adjacent is known, you write it. Then how to find this? Use Pythagoras Theorem. Hypotenuse here you have written H square 5 minus square 4. 5 minus 4 is 1. Square root of 1 is 1. This is how you are going to write, my friends. You are going to write what? Conversion, jumping from this to this, like that, my friends. Next, I am going to write in general. This is sine inverse x. Sine inverse x. I write this as what? Sine inverse x upon 1. What is this? Opposite side. Denominator is hypotenuse. I want to write from here to tan inverse. Tan inverse. What is this? O upon A. O upon A. What is O? X. What is down A? Adjacent side means what? 1. It is square root. H. Square root. Square. Minus square. I wanted to write from what? From sine inverse to sec inverse. This is sine inverse x to sec inverse. Sec inverse. X can be written as x upon 1. What is this? O by h. Here this is h1 upon square root. Pythagoras Theorem. 1 square minus x square. 1 square minus x square. This is how you must write, my friends. Transfer from one to another. And now I want to transfer from tan inverse to. This is tan inverse x to cos inverse. Tan inverse x to cos inverse x. Tan inverse x can be written as what, my friend? Upon 1. What is this? O. What is this? A. Cos inverse A here. This is A. What is A? Is 1. Down you wanted hypotenuse. What is hypotenuse when the other two sides are given? This is square root of x square plus 1 or 1 plus x square. 1 plus x square, otherwise x square plus 1. This is how we can jump from tan inverse to cos inverse. Next, my friend, what is this? Sec inverse x. I want to write from sec inverse to cot inverse. X can be written as what? X upon 1. What is sec? Hypotenuse upon adjacent side. What is cot? Adjacent side above. Adjacent side is 1. Upon opposite side. What is opposite side? Square of hypotenuse minus square of this. It is square root of square minus square of 1 is 1. I hope, my friends, it is clear. And the same while doing the examples which appeared for your exams while doing, I use this method. So up to this, my friends, I have explained what? All the basics of what? Trigonometry as well as what? Inverse trigonometric functions, their properties, definitions, domain, range, trigonometric ratios, everything I explained, my friends. Now I go forward. I will start with the regular examples which are there in your exam, my friends. My friends. Remember. My friends, using the trick conversion of what? Sine inverse to tan inverse to sec inverse, I shown that bridge, short bridge, my friends. Two sides are given, among the two one is used. This remaining one we have to make use Pythagoras Theorem. Pythagorean numbers means we can write directly. Yes, my friends. These are some examples based on that. First, value of sine tan inverse 3 by 5 equal to dash. These are the options: 3 by 4, 3 by 5, 3 by root 34. None of these. Among 4, one option is correct. In this, my friends, we use this property, inverse idea. Sine of sine inverse x equal to x. You know that. Here x means domain comes. X belongs to minus 1 to plus 1. Cos of cos inverse x is x. Tan of tan inverse x is x. That property is given. That x belongs to the domain of the function. Yes, my friends. You wanted both must be same. Sine means it should be sine inverse x. Then only we can write this equal to x. See here. What is this? Sine of tan inverse. You must convert this tan inverse to sine inverse. I explained the method. What is that? It is tan inverse. tan inverse to sin inverse, my friend. This is sin inverse. Opposite upon adjacent side. What is this? Opposite upon adjacent side. Sin means wanted opposite, right? 3 by, see, it is what? 5 is there. Then it is not 4. See, what is sin? Sin is opposite side. This is hypotenuse. It must be what? It is square root of 25 square root of tan. It is sin. Tan means it is this, my friend, 5. 5. Opposite upon adjacent. Opposite is 3. Adjacent is 5. Then what is this side? It is 9 plus 25. 9 plus 25 means it is root 34. Root 34. What is this, my friend? 9 plus 25 is root 34. Sine of sin inverse is, don't write all these things. Directly you can mark. It is 3 upon root 34. I will explain once again, my friends. Sine of tan inverse 3 by 5 equal to dash. These are the options, 4 options. Is correct. Among the 4 options, 1 is correct. Now we want to convert from tan inverse to sin inverse. Why? To make use that property. Sine of sin inverse x equal to x. To convert from tan inverse to sine. What is this? Opposite. This is adjacent. Sine. Opposite upon hypotenuse. Opposite upon hypotenuse means what, my friend? Square root of squares of these two sides. 9 plus 25. What is 9 plus 25? Root 34. Sine of sin inverse is 3 upon root 34. Therefore, your answer is C. Your answer is C, my friend. That is answer is C. Even without doing all these things, we can mark it. Sir, how? C. You have written, I will write once again, that side. Once again, that side. C. This is sine of tan inverse. I want to convert sine inverse. Opposite side is 3. With the 3, there are only 2 options. No, all the 3 options are there. Yes, this is correct. Even we can see 3, all the 3 options. Adjacent side is 4 means it is not hypotenuse. 5 is what? Adjacent side. It is not hypotenuse. Then what is hypotenuse? 3 square plus 5 square. 9 plus 25 is 34. This will be the answer. This will be the answer. Yes, I will tell you. Then another one, same type, one more. Value of this. Then you must convert this in terms of what? Cosec inverse. Cosec is outside, you wanted cosec inverse. What is this cos? Cos means it is adjacent side upon hypotenuse. What is cosec inverse? Hypotenuse. Hypotenuse is 25. Upon opposite side, see, 7, 24. What is the opposite side? Pythagorean numbers. 24. 24. Cosec of cosec inverse. What is your answer? 25 upon 24 will be the answer. Which option, my friends? 25 upon 24 means this is your answer. Answer is C. Answer is C, my friend. Answer is C. Even in this case, C. Even in this case. Even in this case. Cos inverse to cosec inverse. Adjacent, hypotenuse. Cosec, hypotenuse upon opposite side. This is 25. This is 25. With 25, these are the only 2 sides. No. No, not possible. They are the only 2. But what is the denominator? Either 24 or 7. But 7 is there. 7 is there. Then it is also not. So this is the remaining. This is the remaining. Which is 24 upon 25. I hope clear. Cosec of cos inverse 7 by 25 equal to dash. These are the options, my friends. Cos is adjacent upon hypotenuse. Cosec, Hypotenuse. What is hypotenuse? 25. Write 25. After writing 25, see, with 25, these are the options. Then these are not your options. Cancel them. Among the two, one is correct. It depends upon your denominator. Denominator never be 7. Why? It is adjacent side. You wanted opposite side. Then opposite side never be 7. Never be 7 means it is also not there. The remaining one is what? 25 and 24. Otherwise, Pythagorean numbers, right? 24. 24. This is second. Third example. Cos of tan inverse sine cot inverse x is dash. These are the options. Square root x square plus 1 upon x square plus 2. Square root x square plus 2 upon x square plus 3. Square root x square plus 3 upon x square plus 4. Fourth option is x. Fourth option is x. I have written here the same example. Same example. It is cos tan inverse sine cot inverse. Then my friend, sine of sine inverse x is x. We must convert from cot inverse to sine inverse. What is this? X can be written as x by 1. Cot is what? Adjacent upon opposite side, sine, opposite side 1. 1 upon, what is this? Hypotenuse. Hypotenuse means what? Sum of the squares of these two, x square plus 1. Now sine of sine inverse is 1 upon x square plus 1. What is behind tan? Tan inverse 1 upon root x square plus 1. Hi my friends, see, sine inverse is this. Then this is cos of tan inverse this. Tan inverse sine of sine inverse is this number itself, 1 upon x square plus 1. Now my friend, you want to convert from tan inverse to cos inverse. Why? Outside is cos. You want to convert from tan inverse to cos inverse. Cos inverse. Now what is this? Above. Opposite side upon adjacent side. Adjacent side is this. What is cos? Adjacent upon hypotenuse. See. With root. In the numerator, root is only this option, first option. Don't spend your time in writing this denominator. Don't spend your time in writing this denominator. Why? In the numerator, root x square plus 1 is with first option. This is your answer. If this is repeated, find the denominator. If the numerator x square plus 1 is repeated, go for denominator. Yes, my friend. What is the denominator? Root x square plus 1 plus 1. X square plus 1 plus 1. Which is x square plus 2. Then, which option is the answer? A. Option A is the answer. Answer is option A. The same thing, this is alternative method. Still it is brief. Put x equal to 0 where? In the expression as well as in the options. Put x equal to 0 in the given expression as well as options. See, first in the expression, put x equal to 0. Expression equal to cos of tan inverse sine. What is this, my friend? Cot inverse 0. What is cot inverse 0? Is 90 degrees. Cot inverse 0 is 90 degrees. Why tell? Why? This is cot inverse 0 is 5 by 2. 5. Cot 90 is 0. Tan 90 is infinite. Tan 90 is infinite. Cot 90 is 0. Cot 90 is 0. Yes, my friend. This is pi by 2. What is sine 90 is 1. It becomes tan inverse 1. What is tan inverse 1? Pi by 4 with cos. This is cos tan inverse 1. Cos 45 is 1 by root 2. This is your given expression. Put it in the option. Put x equal to 0. First option itself. What is it? 0 plus 1 upon 0 plus 2, root 1 by 2 means 1 by root 2, 1 by root. Therefore, my friend, your option A is the answer. Your option A is the answer. I hope understood. I will explain once again. See, the value of this. These are the four options. Again, you have to make use of this result. Sine of sine inverse, cos of cos inverse, tan of tan inverse, sec of sec inverse. You have to make use. Convert cot to sine inverse. I told the time saving result. X can be written as x by 1. Cot adjacent side upon opposite. It is sine inverse. Opposite upon hypotenuse. This hypotenuse you must calculate. What is it? Root x square plus 1. Hypotenuse is the bigger addition. Root x square plus 1. Sine of sine inverse is what? Tan inverse of this expression. 1 upon root x square plus 1. What is here? Cos. It becomes cos tan inverse 1 by root. Now you convert from tan inverse to cos inverse. What is cos? This is opposite upon adjacent cos. Adjacent is this upon hypotenuse. Root x square plus 1 which is x square plus 2. Option A. Now put x equal to 0. Cot 0, 90 degrees. Sine 90, 1. Tan inverse 1, pi by 4. Cos pi by 4 is 1 by root 2. Cos pi by 4 is 1 by root 2. It is in the options also we can put x equal to 0. 1 by root 2. This is root 2 by 3. Root 3 by 4. It is 0. Therefore, first option is your answer. My friends. Yes, I hope understood. Like this, one more example is there. I am not going to do this method. I directly write what? Put x equal to 0. Same type, one more is there. Yes, my friend. The value of, this is fourth example. Value of sine of cot inverse tan cos inverse x is dash. These are the options. Root x square minus 1 upon x square minus 2. X square minus 2 upon x square minus 1. X. None of these. Yes, I told direct, my friends. Put x equal to 0. Expression equal to sine cot inverse tan. What is this, my friend? Cos 0. X is 0. Cos 0 is pi by 2. Tan pi by 2 is infinite. Cot inverse infinite is 0. Sine 0 is 0. I will explain once again. Put x equal to 0. Given expression. Sine cot inverse tan cos 0 is 90. Why? Cos 90 is 0. Tan 90 infinity. What is cot inverse infinity? It's 0. What is sine 0? Here. Sine 0 is 0. In the expression, these are the expressions, my friend, where this. See, x is 0. Minus 1 upon minus 2 means 1 by 2. This is 2. This, my friend, is 0. Therefore, option C is the answer. X is 0. Option C. I hope understood. This is the next example. The value of tan sine inverse cot sine inverse root 13 upon 17. Sine inverse root 13 upon 17. These are the options. First option is 2 by 3, 3 by 2, 1 by 3, 1 by 2. These are the options, my friends. 1 by 1. This root 13 by 17 can be written as root 13 upon root 17. Root 13 upon root 17. Sine opposite upon hypotenuse. You wanted to convert from sine inverse to cot inverse. Cot inverse. What is the definition of cot? Adjacent upon opposite. What is opposite? Root 13. This is root 13. You have to write this opposite side. Yes. Square 17 minus square 13. 17 minus 13 is 4. What is root 4 is 2. Root 4 is 2. 17 minus 13, 4. Square root of 4 is 2. 2 by root 13. Now, cot inverse, my friend. Cot inverse becomes sine inverse of 2 by root 13. 2 by root 13. You have tan here. Tan. You want to convert from sine inverse to tan inverse. Tan inverse. What is sine? Opposite upon hypotenuse. What is tan inverse? Opposite 2. Before finding this denominator, look at the options. With option numerator 2, in the option is only first option. Therefore, your answer is A. 2 is first option because 2 is here. Therefore, option A is your answer. Now you can find it. What is it? This is adjacent side. Square of the hypotenuse. 13 minus 4. 13 minus 4 is 9. What is square root of 9? 3. So it is 2 by 2 by. I hope you understood, my friend. This is fourth example. My friend, once again, sine inverse root 13 upon 17. Root 13 upon root 17. Definition of sine. Opposite upon hypotenuse. You want to convert from, because cot is there, you want cot inverse. This is what? Adjacent side upon opposite side. What is opposite side? Root 13. How to find it? Square minus square. 17 minus 13 is 4. Square root of 4 is 2. 2 by root 13. Sine inverse of cot inverse. Number itself. Then you have tan. Convert from sine inverse to tan inverse. Opposite upon hypotenuse. Opposite upon adjacent. Opposite is 2. Numerator is 2, my friend. Pi tan of tan inverse. Numerator is 2. Go with this. With numerator 2, but the only one option is there. Mark it. Now, if you wanted denominator, what is it? 13 minus 4, 9. Square root of 9 is 3. You have 3. This another example, my friend. Last example of this class. If tan of cos inverse 1 by x equal to sine of cot inverse 1 by 2, then the value of x equal to dash. Then x equal to dash. These are the options. First option, plus minus 2 by root 5, 3 by root 5, plus minus 3 by root 5. This is only plus 2 by root 5. These are 4 options. Yes, you want to convert from cos inverse to tan inverse this. Tan inverse, what is cos? Adjacent upon hypotenuse. Adjacent upon hypotenuse. What is tan? Opposite upon adjacent. Adjacent is 1. 1. Opposite, root x square minus 1. Hypotenuse is bigger 1. Hypotenuse is bigger 1. X square minus 1 equal to cot inverse to convert in terms of sine. Sine inverse. What is this? Cot. Adjacent upon opposite side. What is sine? Opposite upon hypotenuse. What is hypotenuse? Root 4 plus 1. 5. Remaining 2 sides. Opposite, adjacent, hypotenuse. Root square plus square. Root 5. This is tan of tan inverse. Number itself. This is sine of sine inverse. Number itself. Square both sides. X square minus 1. Square 4 by 5. Shift minus 1 this side. Plus 1. 4 plus 5. 9 by 5. X equal to plus minus 3 upon root 5. If you put that negative value here. Negative value here. This will be what? Cos inverse of negative pi minus this. In that case, that LHS doesn't become RHS. Therefore, x equal to plus 3 upon root 5. That B will be the answer. B will be the answer. B will be the answer, my friends. Yes, my friends, I have done nearly half dozen examples based on this one time saving result I told. What is the time saving result? Directly conversion of sine inverse to tan inverse to sec inverse, like that, my friends. I explained everything, including definition of what? Trigonometric ratios. I gave the link, and with that link I explained, my friends. Remember, very, very useful and important time saving result in ITF, inverse trigonometric functions. My friends, in the next video, I do few more examples on ITF, another time. All these examples are very, very important examples, my friends. Remember, prepare them now only because you are fresh now. The tricks I told, please make them perfect, prepare nicely. Yes, my friends. Thank you very much. If you like it, please share this video to your friends, because CET is very nearer. Share this video to your friends, my friends. In detail you wanted, you can see this inverse trigonometric functions in what? For the main exam I have done in detail by doing 13, 14 videos, my friends, on the ITF. Please refer if you wanted anything you wanted. Otherwise, here I explained everything, my friends. Alright? Yes, my friends. Till to the next class. Bye. Goodbye. Namaste. Namaskara, my friends. Namaste. Good day. Thank you.